Lesson 4.4, Right Triangle, Trigonometry, and Identities. Identities are equations that are true for the entire domain. So no matter what you plug in, you end up with a true statement. We've already met some of these, such as the reciprocal identities. Sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. You need to know these, but to memorize just the red ones. We also have quotient identities. See, these come from, if we remember the unit circle, sine is y and cosine is x. Tangent was y over x. Therefore, tangent is sine over cosine. And then cotangent is the reciprocal. And then we have Pythagorean identities. They come from the Pythagorean theorem. If I put a right triangle in the unit circle, so the hypotenuse is 1, that'd be how far you go on the x and how far you go on the y, but the x is just cosine and the y is just sine. So cosine squared plus sine squared equals 1. The others come from dividing the first Pythagorean identity by either sine squared or cosine squared. Such as if we divide by sine squared, the sines would cancel out, giving you 1. And then cosine over sine is here. So that's your 1, the cotangent, and then we have 1 over sine. 1 over sine is cosecant. And that's how the third one shows up. To get the middle Pythagorean identity, just divide the red one on both sides by cosine squared. And just as a note, sine squared u is the same as sine of u squared. There were some more identities. We have the co-function identities. If you're wondering why we have a sine and a cosine, a tangent and a cotangent, well, if we take a right triangle, we call one angle u. Well, the two acute angles in a right triangle are complementary. They add up to 90. So the other angle would be 90 degrees minus u. So if I call my sides x, y, and h, for example, cosine of u would be the adjacent over the hypotenuse. Sine of the 90 minus u, the other angle, is the opposite, x, over the hypotenuse. Notice they're the same thing. And that is why sine and cosine, tangent and cotangent, secant and cosecant are. You get the same thing if you use the other angle in the right triangle. All right, let's use some identities to figure some things out. So we know cosine is 0.96. What's sine? So we have to think, do we know an identity with sine and cosine? Sure, a Pythagorean identity, sine squared plus cosine squared equals 1. But cosine is 0.96. You square that, you get 0.9216. Subtract, and square root. Usually we would have to do plus and minus when we take a square root, but we know it's an acute angle in a right triangle. We're just going to have a positive answer. So sine is 0.28. Try another. Tangent of our angle. Well, can we relate tangent with cosine? Well, we do have tangent is sine over cosine. And we know sine was 0.28. We just found that. And cosine is 0.96. So if we divide those, you get 0.2917. You could have also used a right triangle. Call that angle theta. Cosine is adjacent over hypotenuse, so I could make it adjacent, there 0.96 over 1. We could use a Pythagorean theorem to find the other side, and then you could use the formulas, like sine is opposite over hypotenuse, tangent's opposite over adjacent, to get the same answers. Let's try another. This time we know tangent of beta. We want to find cotangent of beta. So is there a relationship? Sure, they're reciprocals, so cotangent of beta would be 1 over tangent of beta. Tangent of beta was 4, so cotangent must be 1 over 4. How about secant? Can we relate secant and tangent? Oh, sure, a Pythagorean. 1 plus tangent squared equals secant squared. Tangent is 4. So that makes 17, because 4 squared is 16. And then square root to get rid of the square, so secant of beta is the square root of 17. Again, we could have also used a right triangle, called one of the angles beta. Tangent is opposite over adjacent, make it like 4 over 1. Use Pythagorean theorem to get the other side, and then filled in the formulas. But we did the same process with the identities as we would have by doing it with a right triangle and the formulas. All right, we also have something called the angle of elevation and the angle of depression. They're both measured from the horizontal. Depression, you're looking down, so it's the angle from looking straight out to much you're looking down. When you're depressed, your eyes are always down. Angle of elevation is from straight out and how far you're looking up. Since the since the horizontal is parallel to the horizontal, since they're both measured to horizontal, the angle of depression and angle of elevation are alternate interior angles. And from geometry, you know the alternate interior angles are congruent. So if you need to find the angle of depression, but it's easier to find the angle of elevation, they're the same thing. Not exactly the same thing, but they're the same value. A 12-meter high flagpole. All right, let's draw a picture. So there's our flagpole. It's 12 meters high. Casts a 6-meter shadow, so there's our shadow. And the shadow comes because we have the sun. Find the angle of elevation. Well, the angle of elevation is from the horizontal up, so it would be that angle right there. All right, to find that angle, we know the opposite side and we know the adjacent side. So opposite and adjacent is tangent. So we know it's 12 over 6 or 2. Now we haven't hit the inverse functions yet, but you should have done it in years past. So hopefully you remember to find the angle, we'll use the inverse function, use your calculator, and you get 63.4 degrees.